This is Ampere's circuit law, or simply you can say Ampere's law. What it states? It states that line integral of any magnetic field around any closed loop enclosing a current I is equal to mu naught times the total current I. You know that when a current basically flows through a conductor, this is conductor, in this conductor a current is flowing, and because of that a magnetic field basically produced. If suppose you have to calculate the magnetic field at this point, so you know that the magnetic field lines are moving like this, right, inward. The magnetic field lines are inward into this. The magnetic, this is the direction of the wire, this is the direction of the wire, and at this point here, at this P point, you have to calculate the magnetic field. These magnetic field lines will be inward like this. So you have to consider a circle basically here. This is a closed loop, right, and you have to find out the magnetic field at this point, right. Suppose that is dB because of a small segment of the wire, right, and total, the second point is about the direction of magnetic field. This is the direction of magnetic field at every point. Here you can see that is the tangential, and here if I consider a small segment of the length, that is dl, so vector dl will be towards the same direction as of the b. So here b and dl both are parallel to each other, right. So b and l, as I told you that b is like this, and into the same direction you can consider vector dl. So b and dl both are parallel, right. So the Ampere circuital law is mathematical form is this one: closed path integral b dot dl is equal to mu naught times I enclosed. Here this current is enclosed, only then the Ampere's law is applicable, right. So now again, as you have seen into the Gauss law, that the right hand side is q, and I have converted that into the volume integral. Similarly you can see here that I am converting the Ampere circuital law into the differential form. So I have to convert this b dot dl into the differential form by using the Stokes theorem, right. So in Stokes theorem you know that the left hand side is closed path integral of the vector, that is suppose b. So closed path integral of b dot dl, right, like this, b dot dl is equal to, this is the closed path integral of this field, that is the magnetic field, is equal to the open surface integral curl of the field del cross b ds, right. So here you can see this is the open surface and the closed path is this one. This is the closed path. At every point the magnetic field is tangential, and that is parallel to the vector dl. So if I consider this small segment dl, so vector dl will be parallel to the same direction as of the magnetic field. So here in this Ampere's law, the current I can write here in terms of the current density like this, right. I is equal to open surface integral j dot ds. Now the point is, why you choose here open surface integral, why you did not choose the closed surface integral, right. That physical situation is this one. Here you can see this is the loop, closed loop, and that is shown here, right, and this one is a conductor in which I current is flowing. So this I current is enclosed by this closed loop. I is enclosed, right. So when I am defining the current, I am defining the current through the open surface, right, not by a closed surface. So I is equal to J dot ds. J is the current density. So now putting this value of I in this equation here, it becomes mu naught times and this open surface integral J dot ds. And now I will apply the Stokes theorem. You know that the left hand side closed path integral B dot dl is equal to the this B dot dl is equal to the open surface integral curl of the same field, that is B, curl of B ds. So I can write this B dot dl as equal to this one, and that is written here, right? Del cross B dot ds is equal to mu naught times open surface integral J dot ds. Now you can compare both the side, right? So here open surface integral, this is also open surface integral, so you can compare these two, and by equating you get this result del cross B in del cross B this one and mu naught J, right, inside and dot ds. So in bracket. Now the point is that either this factor is equal to 0 or this surface of the open loop is equal to 0. You know that this surface is real, it cannot be 0. So the next quantity is equal to 0. It means del cross B is equal to del cross B minus mu naught times J is equal to 0, and after simplification you can see that del cross B is equal to mu naught times J. Right, so this is the third equation. Here we signifies that del cross B is equal to mu naught times J.